Let's start with BPM. The BPM is not only used to make beautiful diagrams, but it has a real relevance in the digitization of processes. Specifically, BPM makes it possible to know who should do what and when, and to do so in an automated way. It also allows automated tasks to be executed at the right time with the right data. It is obvious that automating a process not only speeds up its processing, but also avoids the many errors. One must imagine a process in BPM as a set of steps to be performed in a series or in parallel, some being mandatory, others optional, all orchestrated according to the specific context of each process instance. The process model is the general model, and the instance is the execution of the process. For example, in application management, for the same recruitment process management model, each applicant represents an instance that can have a different treatment. BPMN is a standard managed by the international organization, the OMG, which is at the origin a UML standard. BPMN allows us to visualize, formalize, standardize, and automate business processes that makes the process readable and accessible to all. Thus, engineers, managers, and technicians can communicate and instantly understand the design processes by speaking the same language, for example, the BPMN standard. This standard represents a set of flowcharts that allow a visual understanding of the process. Let's take the following example to illustrate a process in BPMN. In this example, let's imagine that we want to manage the process of sending goods. We can see here several important diagrams and figures in the BPMN standard, namely the activities that allow to execute a task, the transitions or tasks that allow to link the different figures together, the tasks which allow to direct the flows towards the following steps. We can see three types of tasks: the parallel tasks of processes that parallel or merge the process, exclusive tasks which direct the process towards a single transaction, and the inclusive tasks which can direct the process towards one or more transitions according to the context. Then we have the events that are automatically triggered when certain conditions are met, and finally the pathways that allow us to know who is in charge of doing what. To better understand how a process works in BPMN, we need to imagine a process instance, like a token that advances in the process and that can divide or merge according to the actions to be performed during the handling of this process instance. In this example, the process starts with the start event, products to be sent. At this moment, the first parallel task splits the token in two. In order to parallelize the processing, on one hand, the products must be packed, and on the other hand, we'll start checking whether or not we need to use a special carrier. Let's deal with this last case. Depending on the decision taken by the office worker, the process arrives at an exclusive task, where, unlike the previous parallel task, only one transition will have to be activated. The order can be seen by mail or by a special carrier, but in any case, the same order cannot be sent via two different carriers. Now, let's imagine that we can use the post office for the transport, at which point the office employee will have the task of checking whether insurance is required for the product. Depending on this choice, the inclusive task makes it possible to know whether one is taking one, the other, or both paths. For example, whether to complete the shipment note or buy insurance, or do both activities. In our case, we'll need to complete the form, and let's imagine that for this instance, we have to take out insurance. In this case, both activities will be activated. When a task is finished, for example, the subscribe insurance, the token will arrive to the second inclusive task. This one allows us to wait until all the tokens from the first task have arrived before continuing the process. Thus, the first token remains on hold in the connection until the task, complete the slip, is finished. And so the two tokens merge and the process continues its progression until arriving at the second parallel connection. This last one, like the previous inclusive task, will wait until all the tokens from the first parallel task have arrived. Thus, when the product packaging is finished, the token arrives at the parallel connection and will merge with the token that was waiting to continue the process. The process is repeated until it reaches the end of shipment management process.